Welcome back to Geometry. We're at section 6.3, Proving Parallelograms. We're going to start, we have shapes up here that are blank, and what we're going to do is we're going to draw in these rules, A, B, C, D, E, F, up above so we can see what they look like. So on this first shape, it doesn't look like a parallelogram. Let's change it so that it looks like one. And we'll try and draw this the best that we can. Alright, and so there's our first parallelogram drawn the best that we can do. Alright, from there it's saying that both pairs of opposite sides are parallel. Now, I'm going to change this and say that both sides of opposite sides are parallel and congruent. If you think back to the rule, that's one rule that we have that makes a parallelogram, is that both pairs of opposite sides are parallel and congruent. So let's show that. And the first thing we're going to do is this is A. So I'm going to put A up here. This is our drawing for A. And we know that opposite sides are congruent. We know that opposite sides are parallel. Opposite sides are congruent. And opposite sides are parallel. Alright, next we have B. It says that both pairs of opposite angles are congruent. So B, we're going to make this shape up here. This is our drawing for B. And we're told that both pairs of opposite angles are congruent. So we'll show both pairs of opposite angles congruent. Okay, and so if we were shown this, then we can then assume that this shape is a parallelogram. We have enough information to prove it. We can show that the opposite sides are congruent and parallel. Now I won't mark this up, but just know that if we're shown this and only this, it then means that we can mark it up to look like A. Just like if we're shown that the opposite sides are each congruent and parallel, then that's going to be true that the opposite angles are each going to be each congruent. So it works both ways. Alright, C, it says that both pairs of opposite sides are congruent. So this is actually going to be A again. I mean, A and C are the same thing. They're saying the same thing. So I'm going to put C next to A because this will be our drawing for A. Whoops, sorry about that. This will be our drawing for A and C. How come it's not letting me do that? Let's try that again. Well, that is weird. Alright, I have a glitch going on here. Let me change this. Let's change that. Let's change that. And is it working? Yes, it's working. So this is A and C. Alright, next for D, it says that one pair of sides is both congruent and parallel. Now, I'm going to put a star by D because this is the one that we miss the most on a quiz or a test. So let's draw it out. One pair of sides is both congruent and parallel. I'll have D be down here. And so it just says one side is both congruent and parallel, one side congruent and parallel. And so if you were shown this and you weren't shown anything else, then we are allowed to say that this shape is in fact a parallelogram. Now, why is that? Well, let's prove that. So I'm going to draw this shape, redraw it down here so I can have some more room. We'll make it smaller. Okay, and so here's my shape. Again, we were told that one pair of sides is parallel and congruent. Parallel and congruent. We're going to draw in one transversal, or sorry, one diagonal, which is also considered a transversal. Alright, and from there, if we think about these two lines being parallel, what that means is that these two lines are each parallel, so alternate interior angles will each be the same. And so we have side angle and side angle. Well, by reflexive property, this side is equal to itself. So now we have side angle side, angle side. So these two triangles are congruent. And what that means, now that these two triangles are congruent by side angle side, I can say that by CPCTC, then these two sides are congruent. And if I prove that these two sides are each congruent, now we're at opposite sides are each congruent. Okay, so we have enough information. So I didn't mark this shape like this one because I just wanted you to see it for what it is, okay, and know that if you had to prove it, this is how we would prove why when we have one pair of sides both congruent and parallel, that we have enough information to then say the shape is a parallelogram. And again, I'm going to put a star by D because this is the one that we forget out of all of them. It's hard to see in a sense, and so this is the proof as to why it works. All right, then now next one we have E, and let's have this one be our E drawing. And so diagonals will bisect each other. Whoops. And so we draw in two diagonals. And so these two sides are congruent. These two sides are each congruent. And if you're shown this and nothing more, that's fine. You have enough information to say this shape is a parallelogram, and you would know that the opposite sides are congruent and parallel. All right, we're going to change F. F is not going to say no. F is going to say consecutive angles are supplementary. That was our last rule that we had that makes a shape a parallelogram. G is going to be no. Okay, so if I want to show that consecutive angles are supplementary, let's just put in values. So 60, 120, 60, 120. And so this is going to be F, drawing F. And we can see that 60 plus 120 is 180 degrees. Therefore, these consecutive angles are supplementary. And again, if you were shown F and you weren't shown anything else, but you were just shown 60, 120, 60, 120, you could then say that the opposite sides are congruent because this is in fact a parallelogram. Also, this is just another way for F. F is in a sense the same to B. Okay, and why would it be that F and B are the same? Well, in B you see that opposite angles are congruent, and in F you see that opposite angles are also each congruent. Okay, and it's also showing that the same side interior or consecutive angles are supplementary. All right, we're going to use those rules. Okay, A, B, C, D, E, F, and G is our no, but A, B, C, D, E, and F to answer these 5 questions. Now, I will say that these problems are challenging. Okay, these aren't easy questions. First problem, we have 2 lines that are parallel. By reflexive, AC is congruent to itself. Since these lines are parallel and it's cut by a transversal, we would know that alternate interior angles are each congruent. I'm going to put 2 marks here. Well, we're also told that you have 20 degrees and 20 degrees. Since these 2 angles are each congruent, by the converse of alternate interior angles, right, we would know that AB has to be parallel to DC. And that's because alternate interior angles, these 2 angles are each congruent. All right, now let's say that you weren't able to realize that these 2 lines were both parallel. Okay, instead, let's say that you missed that. Now, first, I'm going to give the answer. And I'm going to say that the answer on 1 is going to be A because both pairs of opposite sides are parallel. Okay, so since both pairs of opposite sides are parallel, this shape is in fact a parallelogram. I can say yes. All right, now let's say that you didn't notice that these lines were parallel. How else can I solve this? Well, when you look at the fact that you have angle side angle and angle side angle, you can say that these 2 triangles are each congruent. Since these 2 triangles are each congruent, you can then say by CP/CTC that CB is congruent equal to AD, and also that BA is going to be congruent equal to DC. And then you would prove, we've just shown that opposite sides are now congruent. Okay, so you could show this by A or you could show this by C. C or A works in this problem. A was easier, less work shown, okay, but C works too. All right, we're going to do the same for this next drawing. Again, let's put a mark at 62 and 62. That sets up alternate interior angles. That means that it touches segment CD, and this angle will touch segment AB. That means that AB is parallel to CD. These two lines are both parallel. You also have 8 and 8, so put a mark here and 1 mark here. So far, that's all that I'm going to put. Now, from this drawing, we see that answer choice D works. And D works, so yes, the shape is a parallelogram. Why? Well, D says one pair of sides is both congruent and parallel. Now, let's say that you didn't notice that, because D is a rule that sometimes we'll forget is there. So it's always smart, if you can prove that these two triangles are each congruent, then you know that by CP/CTC, all corresponding sides and angles are each congruent. So that's also a great way that you can solve these problems. Let's put 2 marks here. It's shared, it's reflexive. Now I have side angle side, side angle side. So these two triangles are congruent. And by CP/CTC, that means BC has to be congruent equal to DA. And so answer choice A would work here too. All right, next for 3, we have 12. We'll put 1 mark here. We have 12. We also have 1 mark here and 1 mark here. All right, and then by reflexive property, we have BD. As this stands, you might think it's side angle side, but that's incorrect. This is ASS or SSA and SSA. Well, SSA does not prove that two triangles are congruent. It does not prove congruent. So I can't use SSA. This isn't a right triangle. Okay, so I can't prove that these triangles are congruent. I do have alternate interior angles, each being congruent. So that means that, notice that this angle hits BA, so this is parallel, and this angle hits CD, so these two sides are each parallel. Okay, but I only have one set of lines that are parallel. Even though BC and AD appear to be parallel, I can't assume anything. And the only thing I know about BC and AD is that the opposite sides are congruent. Okay, therefore we do not have enough information. This is a no. Okay, I don't have anything up here with A, B, C, D, and E that looks like what I've drawn here. It's close, it's very similar, but it's not the same. All right, 4. These two sides are congruent. These two sides are congruent by vertical angles. These two angles are each congruent. And by vertical angles, these two angles are congruent. But by doing that, I still haven't proven anything. Here I have side angle, and angle side. Clearly, I do not have enough information. This is going to be a no. You can't put marks on segment AC. I can't put marks in here, even though it appears. We know that in a parallelogram that diagonals will bisect each other. That is true. However, we're trying to prove that this shape is a parallelogram, so we can't put marks here just because it looks like this point is a midpoint of AC. We just can't do that. All right, last one, 5. We have a mark here, a mark here. These lines are parallel, so alternate interior angles. That would be this angle and this angle. And then by vertical angles, these two angles are each congruent. Next, by angle side angle and angle side angle, by ASA, these two triangles are each congruent. And since these two triangles are each congruent, that means by CP/CTC, let's put M as our point in the middle. I can say BM is congruent equal to DM, and that's by CP/CTC. So we can put 2 tick marks here and here. And now this looks like drawing E, where we say that diagonals will bisect each other. So we weren't shown that, but through proving these two triangles were congruent, and by using CP/CTC, we then prove that diagonals, in fact, bisect each other. All right, problem 6. We're being asked to solve this problem. It's actually a pretty simple problem. We have that the shape is a parallelogram, so that makes it easy for us. We don't have to do what we did on that previous page. So we're told that WP is 3A, so we're going to put 3A. PY is going to be B. Okay, so I know that these two segments are the same, so B is equal to 3A. And then going for the other diagonal, XP is 2B minus 7, and that's going to equal PZ, which is B plus 2. Solving for B, we get B is 9. If B is 9, A is 3. Pretty simple. Next, we have 3y minus 3 is the length of this side. It's going to be equal to the other side, which is y plus 1. So we set those two equal to each other. 2y is equal to 4, y is equal to 2. Angle x is going to be x plus 40. Angle y is going to be x. So if we add up these two angles, these are considered consecutive angles. So x plus 40 plus x equals 180 degrees. 2x equals 140, x equals 70. To the algebra review, we're going to set each of these equal to 0. So x minus 4 is equal to 0. 2x plus 1 is equal to 0. X equals 4. And 2x equals negative 1. X equals negative 1 half. Alright, again, we set each of these equal to 0. So we get 3x is equal to 0. X equals 0. X plus 5 is equal to 0. X equals negative 5. Alright, this is like saying x plus 7 times x plus 7 is equal to 0. X equals negative 7. X equals negative 7. Alright, and how I'm getting that is I subtract 7 on each side and then solve for x. Alright, to our problem down below, we have what's called special parallelograms. Now this is going to refer to our rectangle, our rhombus, and then a quadrilateral that is both a rhombus and a rectangle is called a square. Okay, so the rectangle, rhombus, and square are our three types of special parallelograms. Now any property that's true for a parallelogram is also going to be true for a rectangle. It's going to be true for a rhombus. It's going to be true for a square. Name a property that is true about the diagonals of a parallelogram. They bisect each other. That'll be true in all of these shapes as well. Mark each figure to indicate this statement. We're actually going to do that later. Okay, so for now, let's go down to the proof. We're going to prove that a shape is a rhombus and what makes a rhombus different from a parallelogram. Now remember, this gets back to mammals and humans. Okay, so we have said that all humans are mammals, but not all humans are, sorry, let's try that again. All humans are mammals, but not all mammals are humans. Okay, so we want to keep that in mind when we think of a parallelogram and rhombus. Okay, so with our parallelogram, we know that all parallelograms are a rhombus, or that all properties in a parallelogram you'll see in a rhombus, but not all properties in a rhombus we see in a parallelogram. Okay, and it works the same way with mammals and humans. So one thing that we know about a rhombus is that all sides are each congruent. And so that's one thing off the bat that makes it different than a parallelogram. Remember that in a parallelogram, we say that opposite sides are congruent. And so we say that these two sides are each congruent, these two sides are each congruent. Well, this is still true for a rhombus. It is still true. It's true that I can say that opposite sides are congruent. But it's also true, so again, this is true, but it's also true that all sides are congruent, where in the parallelogram it's opposite sides. So we just install the word all instead of the word opposite in a rhombus. Now, that's going to change a lot of things, and here's why. Let's draw in our first diagonal. All right, and actually, let's go and draw in our second diagonal. All right, well, just like in a parallelogram, we say that diagonals will bisect each other. And that's true here too. So we can put 2 marks here, and we'll put 3 marks here. Okay, but what we have now created is this is side, 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 side. So these 4 triangles are now congruent. They want us to label the shape pony. So we're going to say P, O, and Y. All right, and by doing that, we've created a few different things. One, we can now say that, and also we're going to put point T is going to be in the middle. So where these points meet, we'll say this is point T. Okay, so now I can say, and if I were to spell out this triangle, let's spell a word. We're going to call this triangle pot. Is congruent equal to triangle knot. Is congruent equal to triangle PYT, which is congruent equal to triangle NYT. Okay, so these 4 triangles are each congruent by side, side, side. All right, well, what's interesting to note now is that if I'm going to call this angle 1, I'm going to call this angle 2, angle 3, and angle 4. Okay, now if I underline this O right here in triangle POT, sorry, that was bad. In triangle POT, I should have underlined, sorry, the T. Let's erase that 1 second. Let me do a hard erase here. Let's get rid of that. All right, and then let's go back to the pen. If I look at angle T, and I'm just looking at triangle POT, but in specific, I'm looking at angle T, that's going to be angle 4. Okay, and when I look at angle NOT, that's going to be angle 1, is angle T. And then triangle PYT, that's going to be angle 3. And then triangle NYT, this angle T is going to be angle 2. Now, since these 2 triangles are each congruent, you know, like angle P is going to be congruent equal to angle N, right? And angle P and angle N here. So these 4 angles are the same as well, because you look at the first letter, first letter, first letter, first letter. Just like angle O, angle Y are all the same, and just like all of these T's, angle T. Well, these are the same angle. Now, if we separate this, and I think about an X, because that's what we have here is an X marks the spot, and I have angle 1 here, angle 2, angle 3, and angle 4, and these are all the same angles, then let's put an X here, because it's an unknown, but all of these angles are the same, so I'm just going to put X. Well, if I add up all 4 angles, X plus X plus X plus X, what has been formed here are 2 linear pairs. You have 180 degrees and 180 degrees. So you have a grand total of 360. When you solve for X, you get X is equal to 90 degrees. That means all of these angles are right angles. They're all 90-degree angles. Okay, and so that's one thing that's going to be different from a parallelogram, is that in a rhombus, the diagonals of a rhombus are perpendicular. Okay, and so that's one thing that's different from a parallelogram. So let's highlight that. You know, this is different from a parallelogram. And I'll just put P-A-R-L. There we go. All right, well, let's get that in writing. So what we just did is, since we have four triangles that are congruent with pot, knot, PYT, and NYT, then what I can say is that angle 1 is congruent equal to angle 2, which is congruent equal to angle 3, which is congruent equal to angle 4. And why are those angles each congruent? Well, CP, CT, C, right? These angles are what's considered corresponding angles. So by CPCTC, all these angles are the same, and they're all 90-degree angles. All right, well, we're not done yet. We have more things that we can mark. Next, go ahead and label. Let's change colors again. This is going to be angle 5, angle 6. We're going to call this angle 7, angle 8. We'll call this angle 9, angle 10, and then angle 11 and angle 12. All right, well, the next thing that I can say is if you look at triangle POT, you see O is that middle angle. I'm going to put 3 marks here. Okay, and so angle O will be congruent to this angle O in this triangle, and it'll be congruent to angle Y in triangle PYT, and it'll be each congruent to angle Y in NYT. Okay, and if you look at angle O in POT, that's going to be angle 5. Okay, so this is angle 5. And then NOT is going to be angle 6, right? Here's angle NOT. Well, we're saying that angle 5 is congruent equal to angle 6. So put 1 mark and 1 mark. These two angles are the same. And if you keep going for angle PYT, you see that angle PYT is angle 9. So angle 5 is congruent equal to angle 6, which is congruent equal to angle 9, which is congruent equal to, and then this is going to be angle 10. So you can put a mark here and a mark here. All 4 of these angles are the same. And we can do the same thing for angles 7 and 8 and 11 and 12. So that's going to be angle P. Let's change colors here. So angle P is going to be angle 7, right? So let's take that up here. We have angle 7, and then angle N is going to be angle 8, and these two angles are each congruent. So we can put 2 marks, 2 marks, and it'll be same with 12 and 11. And so how we can say that is we want to say that the diagonals of a rhombus will always bisect the angles. And so again, this is how a rhombus is different from a parallelogram. You will not see these two traits in a parallelogram. You only see these two traits, 1 and 2, in a rhombus. Thanks for joining us. See you next time.